Welcome back to Arxflix. Today, we'll explore a fascinating paper titled Zero-Shot Text-to-Image Generation. This paper introduces a streamlined approach using a transformer model that autoregressively combines text and image tokens into a single data stream. It promises to deliver high-quality images based purely on natural language descriptions. Here's an example illustrating the encoding and decoding process with the discrete VAE. The model maintains recognizable features, even if some details are lost. Now, let's break down the main contributions of this paper. Traditional text-to-image generation methods often struggled with complex architectures and auxiliary losses. They also relied heavily on annotated data like object part labels or segmentation masks. Over time, improvements came from methods like multiscale generators and attention mechanisms. Yet, issues like object distortion and unnatural blending persisted. The research team investigates whether dataset and model size limitations could be the bottleneck. By training a 12 billion parameter autoregressive transformer on 250 million image text pairs, they show remarkable improvements, achieving zero-shot generation that surpasses previous models. The approach hinges on a two-stage training procedure. The first stage involves training a discrete variational autoencoder, DVA, that compresses a 256 by 156 RGB image into a 32 by 32 grid of discrete tokens, each with 8,192 possible values. This significantly reduces the encoder's context size without major quality loss. Stage 2 focuses on learning the prior distribution. Here, the authors train a 12 billion parameter autoregressive transformer to model the joint distribution over text and image tokens. This diagram shows the per-resblock gradient scaling procedure for stable training in the transformer model. By managing gradient scales at each resblock, the authors ensure that underflow, a common issue in mixed precision training, is mitigated. To make this work, the team sourced a massive dataset of 250 million text-image pairs from the internet. This includes datasets like conceptual captions, but excludes the Mississippi Cocoa captions. They used mixed precision training to save GPU memory and speed up processing. The model, stored in 16-bit precision, required sophisticated distributed optimization techniques like parameter sharding and gradient compression using PowerScript. This figure illustrates the communication pattern used for distributed training, ensuring efficient memory usage and computational overlap. When evaluated zero-shot on the Mississippi Cocoa dataset, the model performed exceptionally well. Human evaluators preferred it over previous models 90% of the time for realism and 93% for better matching captions. Here are the results of human evaluations, demonstrating substantial improvement over DF-GON. The model also excels qualitatively at tasks like combining distinct concepts, rendering text, and even image-to-image translation based on natural language prompts. Shown are zero-shot samples from the CUB dataset, highlighting the model's ability to generalize without specific training data. This paper presents a surprisingly simple yet robust approach to text-to-image generation using a large-scale autoregressive transformer model. It shows that, with sufficient scale and data, the model achieves state-of-the-art zero-shot performance. That's it for today's episode. Don't forget to like, comment, and subscribe for more in-depth research summaries. See you next time on Arxflix. Thanks a lot to Element for supporting Arxflix and providing this wonderful voice.